That's what it was.
There we go. Perfect.
All right, I can already tell that this is a little bit more of a technical audience than I wrote this for, so we'll just go with this. I'm sure everybody has already used a recursive CTE, knows what recursion is. Anybody?
I've used a recursive CTE. I'm thinking probably not the whole class.
Yeah, maybe just a little brief.
Okay. Well, that's good because that's where I started. I wanted to get a pulse before we moved on to slide 1. Okay. So just an overview on what recursion actually is before we get started. Recursion itself is a little hard to define, so we use it in a sentence when we don't know actually how to call things. Recursive query is a query that calls itself in order to grab the final output to formulate a solution. Does that make sense? You happy with that? Okay, great. Usually these are built with hierarchical data in mind. You know, you have a parent with many children, a tree with many leaves. These are things that we think of when we think of hierarchical data. So I put a few examples here so that we can start thinking about how we all use hierarchical data in our ordinary structures. Organizational structures are ones that are pretty commonly cited. If you think about just a table in any database that any one of us have in our companies, the employee to boss relationship is pretty hierarchical. Yeah, we all know that one. A task to a project list. We can all have projects with many tasks in them. A website diagram, if there's a category with leaf pages in it. These are all things that we can map with recursive queries of some type. Common table expressions being one of them. So the anatomy of a recursive CTE. Common table expressions don't get used as frequently as I think they probably should because they look weird. You get this with CTE name as, which doesn't make any sense to anybody. But inside of it, you have this very familiar structure of select something from something. A recursive CTE goes one step further where you're unioning that same query on top of itself, kind of like a self-join, where we get back to that slide 1, that concept of recursion, where it's calling itself to complete your ask. There are a few separate steps that we need to go through to actually accomplish this whole concept of recursion. The anchor query, the separator, the recursion, and the termination check. Sometimes the termination check is implicit, sometimes you actually have to call it. The termination check is pretty important because when you're thinking about the concept of recursion, it's kind of like looping. You don't want to get into the infinite loop kind of concept. You can get into a similar catch with recursion. Aside from the strange way that you start writing a common table expression, this looks pretty familiar. Let's ignore everything below the union for right now and briefly move on to the next slide. This is pretty well subject to regular SQL functionality. You don't have to use union all the time. You can use joins, exceptions, intersect, all of that within this basic syntax. You can even, within the first select, join on multiple tables. This is a template for whatever you need this actual recursive query to do. So you can see here in the second recursion that you have a where clause. I've used where clauses in the first select just so that I'm actually forcing it to do what I need it to do. So I feel like a lot of people, all things told, kind of shy away from this because it looks incredibly formulaic once you're looking at a common table expression, but just like anything else, you formulate the syntax depending on how you need it to be. So that aside, other than that, just a few usage notes that I put in here. We already talked about the union all. You don't always need to use that. Union is great, intersect is great. Multiple CTEs can be called within the same with function. That's with CTE, comma, CTE, comma, CTE, however many you need. They're not physical constructs, so you don't have to drop them within the query in order for them to not persist. And they can be called at any point after the declaration. That's why the recursion concept works within the CTE itself. So, yes?
Just one quick thing that we need to clarify is that CTEs, you don't have to do recursion with them. They have benefits beyond recursion, but they tend to get used mostly for recursion. So what you're seeing up here on usage notes is for CTEs as a whole, right?
This is a great point that I didn't specifically notate in the slides. Yes, CTEs do not have to be used for recursion explicitly. There are non-recursive and recursive CTEs. These usage notes are for all common table expressions. So CTEs I've found are most commonly used for recursion just because there are multiple ways, like drop tables, subqueries, those types of things that you can utilize other than using a non-recursive CTE in your SQL syntax. But a recursive CTE is kind of a special class of thing that gets you around a problem within SQL. So other than that, any questions on why you might need a recursive CTE, what the difference between recursive and non-recursive is, since it is a little bit more of a technical group? Yeah.
I think one thing also, like, you don't have to have a set number of levels sometimes. Like, you could have one and not know how many it's going to be and use the recursion, right?
Yeah, absolutely. The comment was, and the kind of the point behind recursion is that you don't know how many layers deep the recursive formula is going to go. So once it's declared, it does the work for you of delving into how many levels of that one-to-many child relationship it's going to go. You don't have to declare specifically how many layers deep the recursion goes. Yes?
Can you get into issues with an infinite loop? Let's say you started at 2 and you wanted to stop when it was less than 1, which is happening.
Can you say one more time?
Can you get into a recursive loop situation where your starting number is 2 and you want to do the loop until it's 1 and you're adding on every time?
So you can't, the question was about looping, and you certainly can get into a problem with recursive looping, where your query will execute infinitely without returning an answer, essentially. This is where the termination check comes in. So you generally do have to declare either implicitly or explicitly a termination check of some kind. So if you're just iterating through a query to say count from 1 to 50, you're going to want to explicitly state where your number is 50 or less. If you're just going through and saying, give me every child of parent whose name is Suzanne, then your termination would kind of be implicit because theoretically there are not an infinite number of children whose names have a parent of Suzanne. Fingers crossed. So that kind of gets around that issue. Does that answer that question?
Yes.
Okay.